So example 5, it says MNO is a 45, 45, 90 triangle with side length OM equals 2, which you can see over here. What are the 6 trigonometric ratios for angle N with measure theta? All right, so we're told it's a 45, 45, 90, right? We're told that much. So theta is actually equal to 45 degrees, but they're calling it theta just to call it theta, all right? So in essence, what we're doing here is we're figuring out what the sine, cosine, tangent, cosecant, secant, cotangent of 45 degrees is, because theta equals 45 degrees. Okay. It doesn't matter how big or small the triangle is, the relationships for a 45 degree angle are the same always. All right, so obviously we only know one side, we're supposed to know all 3 sides. You might recall with a 45, 45, 90 right triangle, the relationship of the ratio of the sides is 1 to 1 to the square root of 2. You may or may not recall that. If you don't, you need to get that in your brain. All right, that is just pretty straightforward. It's always the same. That's just a relationship that's always there. Now, the 1s are associated with the 45 degree angles. The square root of 2 is related to the 90 degree angle. Anytime you deal with ratios, if you put an x on that ratio, oops, so 1x, 1x, and the square root of 2x. All right? If you have a side related to the 1, in other case this side's 1, right? So 1x equals 2. So whatever this number is what x is. So 1 times 2 is 2, x is 2. So 1x, and x times the square root of 2. So if you know the one side, that's the same, that's times the square root of 2. You can very easily fill in all 3 sides. If you knew this side, you'd have the square root of 2x equals, you divide by the square root of 2 to get what x is, and then you have to go back the other way. So if, for example, this is 10, it'd be 10 divided by the square root of 2. This would be 10 divided, so it would be 10 divided by the square root of 2, so would that. So, again, whatever x is. Or you can use those similar triangles also. Take your pick. So, I know all 3 sides now. I'm dealing with angle theta down here, so I need to identify the opposite side. The opposite side to angle N is side OM, which is 2. Hypotenuse is opposite angle O. The right angle is MN, which is over here, the hypotenuse. And the adjacent would be the other side, which is 2. And this is just like day 1 was now. We want the sine, cosine, and tangent of theta. So sine of theta equals a fraction. Cosine of theta equals a fraction. Tangent of theta equals a fraction. Cosecant of theta equals a fraction. Secant of theta equals a fraction. And cotangent of theta equals a fraction. We're going to use SOHCAHTOA to set up the relationships. SOHCAHTOA. Again, SOHCAHTOA gets us these 3. Sine is opposite over hypotenuse. That's 2 over 2 times the square root of 2, which is 1 over the square root of 2. Okay, I'm going to fix that in a minute, not yet. All right. Is everybody comfortable with sine being 1 over the square root of 2 for now? All right. If I do cosine, cosine's adjacent over hypotenuse. Adjacent 2, hypotenuse 2, square root of 2. So it's the exact same thing. It's 2 over 2 times the square root of 2, which is still 1 over the square root of 2. And then we have tangent, which is opposite over adjacent. That's 2 over 2, which equals 1. Do not feel obligated to make everything a fraction. If it comes out to a whole number answer, feel free to let it be a whole number. That's fine. All right, so 2 over 2 equals 1. That's the tangent. Now, if I go reciprocate these things, I'm going to reciprocate this, reciprocate this, reciprocate this, or that. Take your pick. So, cosecant's a reciprocal sine, so it's going to be the square root of 2 over 1. Secant's going to be the reciprocal of cosine, so it's going to be the square root of 2 over 1. Cotangent is reciprocal tangent. The reciprocal of 1 is 1. So tangent of 45 is 1, cotangent of 45 is 1. Cosine of 45 is 1 over the square root of 2, secant is the square root of 2 over 1, also known as the square root of 2. Sine is 1 over the square root of 2, cosecant is the square root of 2 over 1, also known as the square root of 2. Okay, for this one, recall when we have a radical in the denominator, we don't want that happening, so I'm going to multiply top and bottom by the square root of 2 to get my better structure, which is the square root of 2 over 2. Square root of 2 times 1 is square root of 2. Square root of 2 times the square root of 2 makes 2 with no radical. This is the exact same expression, so it's the exact same answer. Okay. And again, 45-degree angles, those are the trig functions always. Those are always the trig values. Okay. When you get to geotrig, if you go to geotrig next year, we have a test where you have to memorize the sine, cosine, tangent of, or sorry, sine and cosine of every angle between 0 and 360 that would relate to this triangle and the 30, 60, 90 right triangle. All right, so at least knowing what the answers look like is helpful in doing that. So keep that in mind. But again, if it's a 45, 45, 90, it's always got this relationship of sides. So no matter what the side measures are, that's what the sine, cosine, tangent, secant, cosecant, cotangent will always be.